Everyone. Welcome to the October 2024 meeting of the ARCSIX Sea Ice Community of Practice. I'm Angela Bliss. I'm a co-leader of the Sea Ice community, along with Nathan Kurtz, Elaine Runga, and Ignatius Rigor. Today's meeting is our annual Sea Ice update meeting, and we have three great speakers today. The goal of this meeting is to provide updates on recent Arctic sea ice conditions, from satellite observations and forecasting, and also to share updates from some field campaigns that took place this summer. So we'll have time for a couple of questions after each speaker, and also some time at the end of the meeting for discussion and to share updates from community members. So if you have any announcements to share, you can do so with us today at the end of the meeting. So our first speaker today is Walt Meier from the National Snow and Ice Data Center and Series at the University of Colorado Boulder. And he will be giving a talk on the 2024 Arctic Sea Ice Cover and Sea Ice Outlook. So Walt, go ahead and share.
Okay, everyone hear me? Yeah. Okay. Thanks. I thank the IARPIC for inviting me to give an update. And so, oops. Okay, moving slides. So we watch at NSIDC, we have a NASA-funded program project that folks are, I'm sure, aware of. We recently redubbed it. It used to be Arctic Sea Ice News and Analysis. Now it's Sea Ice Today, partly due to the fact that the Antarctic is getting much more interesting and more demand to hear more about that. But today I'm going to focus on the Arctic. And again, folks may have seen or have been following this, but just for the record, we reached the minimum on September 11th. It was the 7th lowest, 4.28 million square kilometers. Pretty close to several other years. There's kind of a bunch up between like around the 3rd lowest and the 7th lowest. Obviously, as you can see, far below the 1981 to 2010 median. A lot of open water in the Beaufort, Chukchi, and Siberian seas. With one exception, which I'll talk a little bit about more later, is this patch of ice, if you can see my cursor, over by Wrangel Island and in the far eastern Siberia. Kind of an interesting, and still not sure exactly what that is. But before we get to that, this is a monthly average for September. It was the 6th lowest September, about 3.5 million square kilometers lost. If you look at the linear trend line, about 12% per decade. That's been fairly consistent over the last several years, right around 12 to 13%, 75 to 80,000 square kilometers per year in terms of the decline. However, if you look, kind of break it up, one thing that's kind of been seen, I've been noticing for the last several years, that since 2007, which was a record low year, it's been pretty flat in terms of the trend. There's a lot of variability, but the trend is quite small, just about 1.5%, not significant, statistically significant, and it's maybe a little surprising for some people, and we hear some people. Some skeptics talk about that, well, now it's stopped declining. But this is, even though it's 18 years, it's still a pretty short period of time. There's been modeling studies that have shown that you get stasis like this with little trend just from natural variability. So it's not terribly surprising, but it is interesting that we've kind of flattened out at a fairly low level, and I'll emphasize, there's been no recovery. The years from 2007 to 2024 are the 18 lowest Septembers in the 46-year record. So we're consistently low for the last 18 years. Looking at the ice age is another thing that we track, and there's much less ice in the much less multi-year ice than in the 1980s. This is at the minimum week just before the ice ages in our product. And so you can see In 1984 on the left, there's vast amounts of old ice, over 4 years old, and most of the Arctic Ocean is dominated by multi-year ice, whereas now there's a significant fraction of first-year ice that kind of is come to dominate the central ice pack, and very little of the oldest ice. Looking at the trend and the extent within the Arctic Ocean region, which encompasses most of the summer Arctic ice cover, except for like the Northwest Passage area. You can see since 2007, similar to the total extent trend, we're not seeing a big decline any further in the multi-year ice. A lot of variability from year to year, but again, very low. And then for the oldest ice, the greater than 4-year-old ice in red, there's a continued decline, I think, as the ice got lost. But after 2012, we've basically been at very low levels, less than 500,000 square kilometers. This year is about 130,000 square kilometers. So compared to when we would have around 1.5 million square kilometers of the oldest ice, so it's about 10% of what we used to have. We do have thickness data. It's not as complete or as long of a time series, but I think the best, most comprehensive data we have it starts in around 2010 with the Cryosat-2 and SMOS from ESA. And it shows similarly, along with the extent and the ice age, there's not a whole lot of trend in this. It's much lower based on other data that we have, like submarines and so forth. Much lower than what we used to see in the 1980s and 1990s, but we haven't seen a continued downward trend. There's a lot of variability from year to year and regional variability. You can see the anomaly in B in the lower left, showing some areas of much thinner ice, but also areas of thicker ice this past winter. That's in April. And then trends, again, some areas of thinning, particularly in the area north of Greenland, but also areas where there's actually a bit of a thickening trend, like in the Kara Sea, for example. Looking at some of the interesting features that we've seen this summer in particular, one that really stands out is the Northwest Passage. This is coming from Steve Howell at Climate Change Canada, with analyses from the Canadian Ice Service, the Operational Ice Service in Canada. And we set a record low in the northern route, the kind of the wide and deep channel through McClure Strait. And really pretty remarkable in a very late minimum, actually at the beginning of October, and it surpassed 2011. We've seen a lot of low years. This is the lowest. It was a little bit surprising because in mid-September, you see there's a little bit of an uptick in the extent in that passage. And that's actually an influx of ice from the north, where the ice has come down from the Arctic Ocean through the channels. And that is not at all an uncommon thing. But this year, that ice melted out and continued to clear out for the next 3 weeks. So we're setting the record low. And as I mentioned, there was a paper that I thought I'd point out that Steve Howell is a co-author on, Allison Cook being the lead author, and that analysis of the Northwest Passage is showing that even though there's more melt, there's less ice overall, and the Northwest Passage has generally been pretty low, at least certainly compared to the 80s and 90s and in previous decades. But because there's ice flowing in from the north, you get this inflow of thick ice that can create choke points and impede potential navigation. So even though the Northwest Passage is opening up to some degree, there is this influx of ice that is making, I think, plans for navigation or future navigation something to be wary about. Another feature that was quite interesting this year was we had a real early opening in eastern Hudson Bay. Much earlier than normal, and actually Hudson Bay tends to open up more from the west first. This was from the east, and we ended up with a record low extent. This was due primarily to strong easterly winds, kind of pushing the ice away from the eastern side west. And so that opened up the ice on the eastern side, and we ended up with a record low ice extent in Hudson Bay from about the middle of May through actually into June and through most of June. This is showing the month of May with this year compared to all the previous years in the light gray lines, and you can see we're much below any previous year. But because the ice got pushed so strongly to the west, on the western side, it really got, it looks like it really got ridged and deformed and had some pretty thick ice that persisted longer than normal. So we actually had an early loss in the east, but a later clearing in the west. Ice stayed around, like you can see there, through the end of July and even into early August. Which was quite unusual, especially in recent years, with the Hudson Bay showing a pretty strong declining trend. Another thing I pointed out at the beginning is this wedge of ice near Wrangel Island, where some old ice, or not old ice, actually, it's first-year ice, but some kind of dirty-looking ice that we noticed first starting in around July, and it was just sticking around there. Even as the ice around it melted away. And you can see here September 1st, I actually saw ice from September 21st. It's actually survived the summer melt season, essentially, this ice. It did decrease some, but it's really quite persistent. And looking at this, it appears that it was really strong flow from the Beaufort and Chukchi, as well as perhaps from coming in from the south, from the Bering, and perhaps and getting kind of crumpled together, deformed, and getting really thick. And the grayish shade to a grayish brownish shade is quite odd as well. I think that's probably sediment. I talked to some other folks that tend to agree it's probably sediment, but it could also be algae. We did also see some smoke from forest fires flowing over that. There could be some deposition from that, but I think most of that is sediment, giving it that odd shape. So this was really quite unusual, and like I said, this persisted through the winter or through the summer melt season. You can see it here. This is at the minimum. And this, I think, I haven't totally confirmed this, but I think this is the farthest southern piece of ice we've seen in at least a couple decades that survived the summer melt, down right near the Arctic Circle, basically. So it's pretty interesting that survived. Whether it has any deeper meaning or longer term meaning, I don't know, but it perhaps suggests that the thinner ice and winds, it's being more easily deformed. And it also helped contribute to a late northern sea route opening, kind of blocking kind of one of the main areas there. And like I said, it did melt, it did last through the summer melt season. Final thing that was quite interesting, we've started to see more of, but a lot of sparse ice, relatively speaking, sparse ice near the North Pole, where there's it's still fairly high concentration, but instead of like 90% plus concentration, it's more like 80 to 90%, where there's visible open water and a lot of small loose flows basically right at the North Pole. We saw this during the Mosaic cruise in a slightly different region, but where the polar stern was able to cruise up quite easily to the pole through broken up ice flows. So I think that's it. Those are the kind of the main things that we've seen this summer, kind of essentially continuing on the long-term trends, nothing extreme in terms of the overall extent or age, just continued low, but some interesting features that we noticed. So thanks to the Christchurch Sciences program for the support, and the other programs there, and Steve Howell for the Northwest Passage data figures, and Alec Petty and Steve Howell, or actually that should not be Steve Howell. Sorry about that, but anyway, thank you.
Thanks, Walt. Great talk. So we have time for a question or two. I see that Kathy Geiger has placed one in the chat. She says, "Hi, Walt, great talk. Can you speak to the increases in snow on ice where the ice is surviving? Are you able to see these types of ship-based operations in the satellite records yet?"
Sorry, could you say that again? It broke up just a little bit.
Yeah. Can you speak to the increases in snow on ice where the ice is surviving? And
Mhm.
are you able to see these types of ship-based operations in the satellite records yet?
Yeah, for snow and ice, that's a good question. Like, we don't have a lot of great data on snow on the ice. There's some reanalysis fields, and there's we do see potential for more snow, but I really don't have we don't have real time data, or at least I don't have good access to that. So I haven't really looked at it that closely. But snow is a key factor. So I think that's definitely great to point out, and I think something that's worth looking at more. So thanks.
Great. Any other questions for Walt?
And I'll just came. Stefan Hendricks is the other that gave the sea ice thickness. Apologies for that at Abby. I just typed that wrong.
I have one. Is it worth trying to monitor sea ice volume change where we have these flat trends in the sea ice extent and not a long enough record to have trends really in the thickness data set? If those things are relatively level, like, do you think the volume has a significant trend maybe over that period?
So we've looked at I didn't show that, but like Stefan Hendricks and the Crysat-2 SMOS, if you combine that with passive microwave sea ice concentration, you can get an estimate of volume. There's obviously some uncertainties there, but the volume kind of essentially shows similar flat trends, variability from year to year, but not a significant trend. There's also like the biomass model observation fusion at the University of Washington, and they use the model to calculate volume, and that also shows really not much of a trend since about 2012. So yeah, everything's kind of flat. I think we've kind of we're in the point where the ice that's remaining and the volume and the thickness is up near the North Pole and north of Greenland, just a harder area to melt. And so we're not seeing quite enough energy yet to really get at that. So I think that's what's going on. Although, obviously, I think worth thinking about more, and other people may have other thoughts as well.
Thanks, Walt.
All right, thanks.
All right, so our next speaker today is Ignatius Rigor from the University of Washington, and he's coordinator for the International Arctic Buoy Programme. So today he'll be giving a talk about a field project that's tracking icebergs in the Arctic Ocean. Right?
Hi, can everybody hear me?
Yes.
Awesome. Yeah, so title slide, lots of collaborators. The list is pretty long, and none of this would have been possible without lots of people, and lots of people that I'm probably forgetting to list on this slide. Our funders are listed below with logos. Typical Arctic Buoy Program, interagency, strong interagency support, and international collaboration. There have been ice islands over the Arctic Ocean for decades. This map shows like the North Pole drifting stations. 4 or 5 of them were on ice islands. There's T3, which is pretty famous. This is a map from Adrian White. They basically, the Canadian Ice Service and Ice Patrol follows icebergs in this pinkish area. This is the current iceberg limit. But as we see from these dots, there's icebergs elsewhere in the high Arctic Ocean. And there's also quite a bit on the east side of Greenland. We have a few ice islands tagged in that area too. But with drifting buoys, we're able to track these a lot better than with the North Pole stations. And so a lot of these tracks here show some of the buoys we have on ice islands. I don't need to tell this group about why it's important to manage this. Walt talked about the Northwest Passage opening. These gray spots are areas of high ship traffic, basically on the edge of the sea ice zone, the marginal ice zone, where there's increasing traffic. And so knowing where these ice islands are is critical for safety at sea. So the Canadian Ice Service has been tracking these for quite a bit, especially north of the archipelago. This map shows some of their efforts to tag some ice islands in 2021. This is with the Canadian Air Force C-130s. I wanted to highlight just one buoy here in particular, MIL 20 A1-B3, since this is probably the longest record we have right now of a ice island drifting through the Arctic, ignoring T3, which was tracked for decades. So this map shows the drift of some of the buoys, or some of the ice islands they tagged with buoys in 2021, or yeah, this is, so starting in 2021, they tagged them here and they drifted through 2023. This berg here is MIL 20 A1-B3 before it broke up into two other pieces, into A and B. And this A here is roughly 2 miles long, 4-ish kilometers. So it's a pretty big piece of ice. And so, the buoy stopped reporting in late 2023. Okay, this is January 2023. And so we put a lot of effort into trying to find it and retag this ice island, since, the Beaufort Gyre is here, and, ice islands here are feeding into a high traffic area. So in October of last year, we have this, we fly monthly in the Coast Guard C-130s to deploy buoys, but also do drop ARCSIX and drop SONs up along the 150 West line, which is shown here. And all these dots show the locations of icebergs that we're going to try to tag. Quite a few were under the ice island, or quite a few of the ice islands were actually under the flight track. This picture here on the right is one of the ice islands as seen in this area during the Joyce. This is from the Louis, so it's the Joyce B-Gap cruise. Unfortunately, the C-130 sprung a leak and we weren't able to tag the ice islands that October. And so our next opportunity was a flight with a Air National Guard, Alaska Air National Guard. We flew in July 2023 with them for the first time, and then they were willing to do a midwinter air deployment, which is wonderful. This is something the Arctic Buoy Program has been working towards for years, mostly to deploy buoys on the Russian side of the Arctic Ocean, given the prevailing drift of buoys and ice away from that coast, with primarily higher AO conditions. These dots show the current location of some of the ice islands in December 2023. These pictures show various buoys that we've dropped. This is an ARCSIX Air. This is our big AXA buoy, and this is also the AXA buoy. And so for 2023, the main goal was to fly along the Russian border to reseed the array in that area. And then on the following 2 days later, we flew into the Beaufort to try to tag some of these ice islands. This is our flight plan for January. We basically flew out to this point, worked our way as far north as we can, given gas constraints, and then flew back along the border to tag these ice islands. Yeah, and then on the first day, we actually flew this line where we were reseeding the Beaufort, but also putting some buoys upstream from the upcoming ARCSIX camp, and that happened in February, March of 2024. So this is a satellite image of the iceberg. They stand out quite a bit in RadarSat and RCM. We got a lot of support from the Canadian Ice Service and the U.S. National Ice Center to keep track of these coming up to these flights. But depending on weather and how fast, we there's a rough rule of thumb that these things will drift with 2% of the wind and mostly with the sea ice. But the wind forecasts need work. And so when we're going up there, this pink dot here on the right radar map is where we expected to see this iceberg. Again, this is MIL 20 A1B3A. But as I started getting used to looking at the radar on the plane, the ground radar, I started realizing that like features like this, where you have a bright spot on the leading edge of the berg and then a shadow behind it, is probably the berg. And I kind of figured this out from staring at the Barrow sea ice radar probably too much. But you see these bright spots and shadows behind it when you're looking at the ridges and ice moving across the Barrow radar. So rather than drop the buoy here, we flew another 10 miles out to this spot and dropped this buoy. So this is an ARCSIX Air buoy. There's the lead on one side of the ice island. Now you can start to see the island and the undulations on the surface of the ice island. And so this buoy actually landed just slightly on the edge of the iceberg. Come this past August, we flew again with the Air National Guard. This flight is wonderful. They chalk it up as a training flight, but the range on the C-17 is pretty amazing. So, like on the first flight, we flew all the way to north of the Laptev Sea, and again dropped buoys along the Russian border to receive the array. Like if we weren't able to drop these buoys, essentially most of the Eurasian Arctic would be observation free. And then on the way back from this flight, we tried to tag this one iceberg, and then on the second day, we put more effort into tagging these icebergs in the Beaufort. And then this iceberg in particular is MIL A1B3A, which we tagged in January, but we wanted to drop multiple buoys on these, partly to help Monica and Daniel Watkins to look at rotation of icebergs and big pieces of ice in the Arctic. So this is a video of us tagging, oh, come on, that buoy again, or that bird again. Similarly, it's kind of tough to see these on the radar on the plane, but we got pretty lucky on this guy where it cleared up and we were able to see through the summer stratus. Lots of melt ponds. I'd love to see how rough the surface actually is and get more estimates of the topography of this island. Yeah, and so we've been tracking this island for a while. We have quite a bit of Landsat imagery of this island during summer. We've also been targeting it with Planet SkySat. So this is one of the images. This was where we thought the ARCSIX Air buoy was when we deployed it from the January flight. The green dot. But looking at coincident or spatially overlapped images from different times, we actually think the ARCSIX Air is on the edge now, and then the second ice ball that we dropped is more in the middle of the flow. Let's see, and then the Sikuliak, we've been working with the National Ice Center and the North American Ice Service, but also with the Alaska Sea Ice Program. Mike Lawson was actually on the Sikuliak this summer. He's one of the analysts there, and they just happened to come by this iceberg, ice island, MIL 20 A1B3A. The wonderful thing about this is that they were able to get an estimate of the height of this berg from the radar altimeter on this C-17. It was bouncing between 20 and 30 feet, so we figured it would be roughly 10 meters. But from the Sikuliak, they measured a height above the ocean of 14 meters. So this thing's about 140 meters thick, which is pretty pretty big, and 2 miles wide, so wide that they couldn't quite get they were a half-mile away and they couldn't quite get the whole ice island in view. Let's see. So this map shows 3 other icebergs that we have buoys on. So here's that one I've been talking about. There's also B3, B3, and then B3, B2. B3, B1, basically the B fragment broke up into 3 pieces and we're trying to track them. We're not quite sure this buoy is on the berg, but we're working to verify that. We already have quite a bit of analysis in progress. In this map, we show the drift of buoys in the neighborhood. The red track is the big ice island that I've been talking about, and then the green track is a sea ice mass balance buoy in the area. One thing we see for the most part is that as the ice concentrations are high, the iceberg will drift with the sea ice for the most part. But once the ice concentrations start dropping to below 3/4 tenths, the sea ice moves a lot quicker, almost twice as fast. So just to summarize, we've been putting a lot of effort into tagging icebergs in the Arctic Ocean, the Beaufort and Chukchi Seas, as well as in Baffin Bay and east side of Greenland. Most of these buoys have barometers and GPS and surface temperature. The ARCSIX air buoy also has a 1 meter air temperature sensor. Yeah, and so right now there's roughly 10, almost a dozen icebergs that we're trying to keep track of, just because this is a big issue for safety at sea, and it's understanding how these things drift is important to be able to predict how they drift in the future. Thank you.
Thanks,
Any questions?
Ignatius. Yeah, we've got time for 1 or 2 questions for Ignatius. Do you think you'll have the opportunity to go back and re-tag some of these if you lose a buoy or they break up into multiple pieces?
Yeah, our next flight is going to be in January, and I've been talking to Adrian White. They try to tag some in the archipelago this past summer, but unfortunately, most of those buoys didn't report. And so we're going to make, we're considering flying in there in January. The trick is that it's going to be a little cold and stuff, and these islands that we were looking at shattered basically, and so we'll have to shotgun it and put out a lot of smaller buoys to try to get some tags on them. So yeah, we're I think for most of our flights, whether it's this coming January and then the upcoming summer flights, this is one of the things high on our radar.
Yeah, thanks. There's another question in the chat from Linette. How long do the icebergs last for in the Arctic Ocean?
Well, T3 spun around for 2 or 3 decades, so they could last a while. I should look back to see how thick T3 actually was. But this guy, A1B3A, it hasn't changed in area that much, and we don't really know how much it's changed in height. But yeah, I'd love to keep track of this until it, melts out.
Great. And one more quick question from the chat from Daniel Watkins. Do you find that the islands you've tracked usually end up melting out in the deep water or getting grounded near the coast?
We've seen some get grounded near Barrow. From like in 2020, there's like a 500-meter rubble field with lots of big icebergs, glacial ice. Andy Mahoney did an ice isotope study. Like he took a core and sent it to the lab and figured out that it came from Milne. So yeah, some of them do get grounded. A lot of those icebergs we tagged in Barrow that year ended up drifting to the Eurasian side of the Arctic Ocean and then caught the coastal current south and actually drifted south through Bering Strait, which was totally unexpected. And then we have Rebecca Woodgate and others have moorings in the strait, and some of those got dragged. And yeah, and so these ice islands could, were probably the culprits in Rebecca losing a few moorings.
Great, thanks, Ignatius. In the interest of time, we'll move to our last speaker, but there are some more questions in the chat that we can maybe bring up at the end of for the discussion, or you can address there. So thanks, Ignatius. Okay, so our last speaker today is Linette Boisvert, who is Assistant Lab Chief of the Cryospheric Sciences Laboratory at NASA's Goddard Space Flight Center, and she's also the Deputy Project Scientist for NASA's Aqua satellite. So today she'll be giving a talk on sea ice conditions observed during this summer's ARCSIX campaigns.
Cool. All right, I guess let me share my screen and put in presenter mode. All right. So can you see my screen? Just making sure.
Perfect, yeah.
Okay, cool. Yeah, so I'm going to talk about the sea ice conditions that we saw during the ARCSIX campaigns. I'll go into detail about what ARCSIX is for those of you that don't know and all of that fun stuff. ARCSIX stands for the Arctic Radiation Cloud Aerosol Surface Interaction Experiment. It's a large mission. I think there were over like 80 people in the field for these two campaigns. And it was led by Sebastian Schmidt and Patrick Taylor with help from lots of other experts in their respective regions of the experiment. So it's an airborne campaign. ARCSIX was an airborne campaign. It was done in two parts in this late spring and early summer of 2024. We were based out of Patuxent, Greenland, and the first campaign took place at the end of May to mid-June, and then the second campaign took place end of July to mid-August. We wanted to understand how the coupling between the radiative processes and sea ice properties influence summer sea ice melt. We also wanted to understand the processes controlling the cloud regimes and their properties, and then improve our ability to monitor Arctic cloud radiation and sea ice properties and the processes and interactions between all three from space. So we had two planes. Well, we had three, a third one in the summer campaign, but two primary planes. We had a high flyer, our NASA G3, and on that we had dropsondes, so we could collect temperature, humidity, and wind profile measurements. We had an Avaris NG imager, and we were also able to take vertical profiles of the aerosol and cloud extinction profiles, and the amount and phase of the clouds as well. On our low flyer, we threw the NASA P3, and so we had more instruments on this, and we were able to collect a bunch of measurements on aerosols, meteorology, so like the winds, temperature, water vapor, even more information on the clouds, their microphysical and bulk properties, trace gases, also getting radiation measurements, so the shortwave and longwave fluxes, and also the albedo and reflectance of the surface, the cloud properties and vertical structures, and then also a bunch of sea ice properties, so like surface temperature, freeboard, and melt pond fraction from this as well. So this is just a figure showing the setup of their two airplanes and how we would plan to measure things. And all the instruments on board are for each plane are listed here, just to give you an idea of our capabilities. It's kind of a unique thing to have all these instruments together, flying two planes simultaneously in the Arctic, because normally when we do a campaign like Iceberg, we were mostly measuring just the surface properties, and now we're trying to get the full picture with the atmosphere and surface and how they're interacting in this time of melt. So we also were able to deploy 9 sea ice mass balance buoys. They were deployed by Chris Polachensky in early May of this year. So this figure on the top left shows all 9 buoys at the start of our campaign. So like the little bullseye circles are where they were in May of 2024. And the blue dots are where they started in early May. So you can watch them, how they drifted. And all of the data for these buoys is online at this website. All the buoys collected temperature data, pressure, their location, the sea ice thickness and the snow thickness, and then the long wave and short wave radiation measurements every 4 hours about. They transmitted back to us. And so we really wanted to, the reason why we wanted to have these buoys is so that we could revisit the same ice essentially in the first campaign and the second campaign to see how the sea ice was evolving with the changing atmospheric conditions. The figure on the bottom right is just showing the drift tracks of all the buoys that survived the summer melts and their locations at the end of our campaign. So most of the buoys shuffled around back and forth in the Lincoln Sea just north of Greenland. But one of our buoys went out to the Fram Strait. So Patrick Taylor made this scorecard in order to evaluate our success for the campaign. So we had 12 different mission goals that we wanted to assess. And we came up with the number of flights or portions of flights that we needed in order to say we, effectively measured these variables. So that's what's showing on the left, and the right was the 18 flights that we did in total from both the campaigns, the spring and the summer campaigns. And we were very successful, I think, especially with dealing with the weather and sometimes the harsh takeoff and landing conditions. But overall, with these 18 flights, we think that we were able to get around 94% of what we wanted to out of the campaign. So it was a pretty big success. These are the ARCSIX flight lines for both of the planes for both campaigns. So the G3 is on the left and the P3 is on the right. So we have pretty good coverage, especially in the Lincoln Sea where the buoys were located. And then even a little bit farther to the east, north of Station Nord, and then farther to the west, north of Ellesmere Island as well. Since we're talking more about sea ice, in each of these flights, these P3 flights, we had some surface characterization legs. So, flying at the optimal altitude for Elvis, which is where our laser altimeter on board, to monitor like the freeboard and the melt pond fractions of the sea ice. And we were also able to do one coincident IceSat-2 underflight in the second campaign on August 2nd. So this figure on the bottom right is just showing our track, the IceSat-2 track in red and our P3 track in orange. We were hoping to do this in the spring campaign as well, but IceSat-2 was in safe hold mode because of a solar storm that knocked it out of its orbit. They were able to get it back working again. So in the second campaign, we were able to underfly IceSat-2. Here's just an idea of what the sea ice looked like in the first campaign. So it was pre-melt. The ice is more compacted and ridged. There's snow on top. It's wind blown. We tend to have more clear skies, less fog. And then in the summertime, in the second campaign, after melt had started, you can see the sea ice is more broken up. You have lots of melt ponds on the sea ice of varying thicknesses, and there's definitely more fog and more moisture in the atmosphere at that time. So every day we would monitor the buoys, and we could also, the great thing about having these buoys is that we could monitor the sea ice changes in between the two campaigns as well, which was helpful. But at each buoy, essentially, so the thickness is the blue and the snow is the white on top. We can see the change in the thickness and the snow depth. So for most of the buoys, we had a buildup of the snowpack over the late spring, early summer, when we had some snowfall events. And then melt onset occurred, the snow began to melt, and then the top of the sea ice also began to melt as well as some melting from below at some of the buoys. We see that in that's what happened to all the buoys, with some buoys having a more abrupt drop off of the snowpack and the sea ice compared to some of the other buoys farther to the north. One cool thing is we also monitored the weather forecasts each day, and we were able to see some precipitation that was occurring in our models, and then we'd look back at the buoys and see, yeah, there was a jump in the snowfall. So we were able to see this kind of thing happening, and also potentially monitor it on some of our flights as well after the fact. So it's kind of exciting, a new thing that hasn't really happened in the past. The buoys also have a thermistor string that measures the temperature from the top of the snow through the ice to the bottom of the ice, and we look at this temperature data every day to try to see where melt onset occurred, so where the freezing point got close to zero, and because we were really hoping that at the end of our first campaign, we'd capture melt onset. We really wanted to capture this, and we were hoping the conditions were right. And so looking at the buoys, for most of them, we believe that we were there during the campaign. That occurred like June 12th, 11th at some of the buoys, 14th. And so we think we were able to capture this and fly over and do a buoy survey right before the end of the campaign, capturing this transition. And looking at the passive sea ice microwave products for 2024 for the melt onset, it shows similar results to what we saw with the buoy. So we are confident that we caught this melt transition. So at the end of the first campaign, I just looked at the change in the sea ice thickness and the surface melt. So at the end of the first campaign, we had a loss of all of the snow cover basically on all of the buoys, and then the sea ice thickness was also starting to decrease as well from the summer melt. So this was the start of the summer campaign, but looking back from the end of the first campaign. So we were monitoring these thickness changes, and it was interesting to see some buoys losing more ice than others. I think buoy J, this buoy down here, it had the most snow cover on it, and I think that helped insulate it a lot from melting. So even though you'd think it's lower latitudes than buoy P, it lost the sea ice melted much slower overall. And during the second campaign, in this at the height of melt, we were kind of puzzled. This doesn't happen so often, but it happened this summer where we have this large opening of the sea ice pack just north of Station Nord, and very low sea ice concentration going all the way up to the North Pole. Walt mentioned this as well. But it was kind of interesting to see because, something we weren't expecting to be happening. We think winds coming out of Fram Strait that were persistent for a while kind of like pushed the sea ice northward and out of the way. We were able to have a surface survey of the low sea ice concentration here at this time, which is, so hopefully we can do some good science from it. And this is just showing the sea ice concentration anomaly, the blues on this day compared to the past 20 years. And so indeed, this is like an anomalous event that we don't always see in this area. At the end of the summer campaign, we had lost Buoy J because it drifted out into that open water area. But we saw large surface melt from all of the remaining buoys and also sea ice thickness melt as well, except at Buoy N, which has got compacted mostly in the sea ice. We still have 4 buoys left today out of the 9. So that's kind of cool. This is what they looked like as of yesterday. Not so sure how well they are recording, but they at least gave us good data from before and through our campaign. So it's always helpful. And then last slide is just showing some quick look data that we have from some of the flights. So the figure on the left is showing the surface elevations from Elvis. So you can see the reds are like the ridges of the sea ice, and this darker blue is the sea ice lead. So we're hoping to get some good freeboard data from that. And the figure on the right is showing the spectral surface albedo from the first campaign in the blue lines and the second campaign in the red lines. And you can see a drastic decrease in the albedo from pre-melt to the height of melt season. So that's also something else. And, we're hoping, really excited to get our data. It's being processed right now to actually do some cool science with everything that we collected. And that's it.
Thanks, Linette. We've got a few minutes for questions here at the end of the meeting. We just got one question in the chat. How you determine the snow depth over sea ice with the buoys?
Yeah, so that is a good question. Essentially, they have a temperature string that runs from the top of the sensor. It's about 70 centimeters above the surface, and it goes through the sea ice, through the snowpack and the sea ice. I'm not the biggest buoy expert. I'm not sure how they determine that the snow ice interface. Maybe, but that is a good question. I know there's definitely people, I don't know if they're online, but I know there's, like, if you talk to Chris Polachensky or Melinda Webster, she would know the answer more so than me, sorry. Oh.
There's a couple ways to do it.
Thank you.
The IMBs have pingers, and so they can see the top of the snow. And then with a thermistor string, if you look closely at the data, the air has quite a bit of variance. The snow has a little less variance. The ice is even less than that. And so you can see the interfaces, at least roughly, between the thermistor string sensors.
Okay, thank you. That's exactly what I needed.
Great. Do we have more questions for our other speakers or a general discussion? Also, if you have community announcements, feel free to raise your hand to give those out or put them in the chat. This is the final minute of free time to ask questions. Thanks. One more question in the chat. So I wonder what was measured for surface ice melt.
I noticed that the number, when you say change, the number was positive. I wonder what was measured. Was melt water or?
So I'm guessing what they do is, like Ignatius was saying, they take the top of the pinger and the semester string, and as the ice melts, I guess that distance increases, like where the ice air interface is. So that's how they do it, and they just say, oh well, the ice used to be this tall, now it's this tall, so they count that as surface melt, I guess.
Okay,
Yeah.
that makes sense. Thanks.
Yeah.
The thermistor string's pretty cool. So between the pinger at the top, and once the snow goes away, then you're looking at the ice surface. But this is a tube buoy, and as the melt goes on, that tube's going to slip through the ice and move to neutral buoyancy. But yeah, if you just watch the data, you can tease it out.
Thank you.
I see one more question in the chat. Will the future analysis include surface and deep currents?
For ARCSIX, or no?
Is that for me or Linette?
Jessica, do you want to? Oh, ARCSIX.
Yeah, so we didn't do anything with the ocean for ARCSIX, just surface atmosphere interactions. So sadly, no. But I know there were a couple icebreakers out in the Arctic this summer in like the Lincoln Sea region. And they were doing more ocean related research. So they might have some data.
Right. Thank you, everyone. We're at the 1 minute past. So thanks, everybody. Thank you to our speakers. These were some really great talks, and I was glad to hear all of the work that you guys are doing.
Thanks, everybody.
Yep,
Thank you.
Bye.
Thanks, everyone.
All right.